Welcome to the second lesson of PyroEDU's Introduction to Microcontrollers course. In this lesson, we'll go through an overview of what a microcontroller is. Specifically, we'll look at the ATmega328 that we'll be using. Then we'll build up our first experimental circuit that I like to call the Hardware Hello World circuit. So what is a microcontroller? A microcontroller is many things combined into one integrated circuit. If we were to look at a high-level diagram of modules, a microcontroller would consist of a processor, flash memory for storing programs in a ROM, RAM memory for the programs to use, and many other sub-modules that provide hardware peripheral features like general-purpose input and output, hardware timers, analog to digital converters, and many other different types of peripherals. The datasheet for the ATmega328, which you can find at Atmel's website, contains all the information about each module that I just listed out. Let's start by looking on page 2 of the datasheet. Here you can see what is called the pinout for each of the different styles of ATmega328 devices. We're using the 28-pin device, so let's focus on that one. Let's get rid of everything in parentheses so that the pinout description is easier to read. This microcontroller consists of three main input and output banks: PB, which stands for port B, PC, which stands for port C, and PD, which stands for port D. Then there are the VCC and ground connections for powering the device. The Arduino platform that we'll be using simplifies things even further. When using this ATmega328 microcontroller with Arduino, there will be 6 different types of connections: the reset, TX and DX for programming the device, digital pins, analog pins, 2 oscillator pins, and then power and ground connections. Now let's dive into the theory of what the basic schematic looks like to program this microcontroller and to tell it to turn on an LED. But let's build it up part by part so you can see clearly how things fit together. First, we'll build the power supply. Our power supply will use a 7805 plus 5 volt regulator and a 9 volt battery. The 9 volt battery connects to ground and to the input of the 7805. The 7805 also connects to ground and then regulates the 9 volt battery down to plus 5 volt. We'll also add 2 capacitors on the input and output of the regulator to make sure enough current is available to the circuit. We'll also add a resistor and an LED to let us know power is connected and good. Next, we'll build the microcontroller circuit. We're using the ATmega328 with an Arduino compatible bootloader already installed. We connect it to the 5 volt power from the regulator as well as to ground. Then from digital 13, we connect to a current limiting resistor and an LED to ground. Now we'll build the reset circuit, which consists of a push button that connects to pin 1 reset on one side and ground on the other. A 10 kilo ohm resistor is used on the left-hand side to pull up pin 1 to plus 5 volt until the push button is pressed. This is called a pull-up resistor. Next, we'll connect the USB to serial converter to the microcontroller. First, we connect TX to RX and RX to TX. These are the transmit and receive data lines. Now we connect the ground to ground. And finally, we connect the DTR line to a 0.1 microfarad capacitor, which then connects to pin 1 reset. This circuit will be used to load our programs onto the microcontroller. The final part of this schematic is the frequency control. For this, we'll use a 16 MHz crystal that connects to the X1 and X2 pins. Each side of the crystal also has a 22 picofarad capacitor connecting to ground. And that's it. Our schematic is complete and the circuit is ready to be built. Before we can dive into the software side of the theory, let's make sure everyone has the Arduino development environment. Luckily, it's very easy to find. Simply go to arduino.cc in your internet browser, click on the Download tab, and then scroll down a bit. Here you'll find their latest version. At the moment, it happens to be 1.0.5. We're using Windows, so we'll download the Windows installer. The install process is like with any other program. You run the installer and it does all its magic. And after a little while, everything is on your system and ready to go. Inside of the Arduino tool, you can find many different example programs to look at. as well as a variety of other tools you can use with your microcontroller. So now let's continue with the theory. The software side of this basic circuit consists of only 6 lines of code, which serve as an introduction of how Arduino code is written. There are 2 functions, a setup function and a loop function. In the setup function, we put everything that we want initialized before the loop code should run. For this example, we want to turn on an LED. Looking back at the schematic, our LED is connected to digital 13. So we need to tell setup that digital 13 should be an output. Then we go down to the loop function and write that digital 13 should be a logic 1 or high. So this program should set digital 13 to our operating voltage of plus 5 volts, which is also a logic 1, and thus turning the LED on. To make sure our code is good, we click Verify, which compiles the program with no errors. Before we can dive into the experiment, there's one other thing that you need to install on your computer, the Virtual Communications Port driver for the USB to serial converter module. To get this, go to silabs.com in your internet browser, click Products, now click Interface, and then click on USB Connectivity Bridges. We're using the CP2102, so select that one. Then click Tools, and finally click the Virtual COM Port VCP download link. Again, we're using Windows, so we'll download that driver. As with before, unzip the package, run the installer, and let it do its thing to get the virtual communications port onto your computer. With the final program installed, let's actually build this thing. Here are the parts we'll need: a jumper wire kit, the parts kit, and a breadboard. Specifically from the parts kit, we'll be using a 7805 voltage regulator, 2 100 ohm resistors, 1 10 kilo ohm resistor, 1 0.1 microfarad capacitor, 2 10 microfarad capacitors, 1 push button, 1 16 megahertz crystal, 1 ATmega 328 microcontroller with an Arduino compatible bootloader installed, 2 red LEDs, 2 22 picofarad capacitors, 1 9-volt battery, 1 9-volt battery connector, 4 jumper wires, 1 USB to serial converter with jumper wires, and a laptop with the Arduino development environment installed on it. With all the parts ready, let's go through a part-by-part construction of the circuit. First we start with the breadboard and the 9-volt battery connector. Then we start building the 7805 power supply circuit, connecting it to the power bus lines and adding 2 10 microfarad capacitors. We use 2 orange wires to connect the power and ground bus lines together, and then add the resistor and power notification LED. Next we'll add the microcontroller and connect it to power and ground. Green wires are used for power and blue wires for ground. Now from digital 13, we'll connect the resistor and LED to ground. The reset circuit starts with 1 wire to ground, the push button, and then a connection to pin 1 reset, followed by a 10 kilo ohm resistor connecting pin 1 reset to power. The frequency control circuit has the 16 megahertz crystal connecting to X1 and X2, and then 2 22 picofarad capacitors connecting from X1 and X2 to ground. Now we add a 0.1 microfarad capacitor to pin 1, and that leads us to the final step, which is to connect the USB to serial converter to the microcontroller. We start by connecting the converter's RX pin to the microcontroller's TX pin, then the converter's TX pin to the microcontroller's RX pin. The DTR pin connects to the 0.1 microfarad capacitor, and lastly, ground connects to ground. Connect the USB to serial converter and check that the correct serial port is selected. You might have to try both or all of them to find out which one is the correct one for your computer. And now finally, click the upload button in the Arduino program. It will compile and download our program, and then the LED turns on, which means our program is running. But wait, let's double check to make sure this is for real. Go back to the Arduino program and change the high in our program to a low. and click the Upload button once more. This time, the LED stays off because the pin remains at logic 0 or 0 volts. Hooray! We now have a setup for loading programs onto our microcontroller. Say it with me. Hello world! A great resource for anything Arduino related, whether it's hardware or software, is arduino.cc. They have all the documentation for how to program Arduino code, along with many, many examples. The Atmel website also contains a vast amount of information about the ATmega328. We really recommend that you download the datasheet for the device that we're using, as it describes every detail and feature inside of the microcontroller.
All parts in this online course were provided by the Gadgetory. Visit them at gadgetory.com/PyroEDU.
Getting a microcontroller platform up and running is arguably the most difficult and frustrating part of the learning process. With that out of the way, now all the real fun can begin. Let's continue on and learn about general purpose input and output.